Yes, and hello! Last time on the Devcom Tutorials series, coding for Unreal Engine in C++, we started creating a little implementation of Conway's Game of Life. And we set up our initial actor so that we have something that can, well, be our cell that's either alive or dead, not both at the same time though, in the scene. So we actually have something to see. We did the basic setup of that. So it shows a static mesh for being alive and a different static mesh for being dead. Today, we will be continuing and extending our actor so it will be clickable. So you can set an initial state of the cell before the actual game starts. And we will start implementing the actual, well, yeah, let's call it game logic. It's not so much, it's not very complex, which I think is the reason why this is a very good example for a tutorial series. But yeah, we'll be implementing the logic so things actually start happening. So let's get started, shall we? Yes, and here we are. Welcome to everyone who's watching this live and who has already joined in the chat, and of course everyone who later on will watch this on YouTube, the recording. Also a very warm hi and welcome to you as well. So, yes, hello there. I just said that. Welcome to part 2 of the creation of a little implementation of Conway's Game of Life. I just said it last week. We set up our initial actor. I will briefly go through the things that we did last week. If you missed it, you can rewatch everything, also the episodes that were before them. This is the 4th episode, so the first 3, you can watch them on YouTube. And if you're a person far in the future and the series has come to a conclusion, you can of course watch everything that follows also on YouTube. Yes, so we have a complete archive of everything that happened here on YouTube. Still, I'll be going quick rundown of what we did last week so we can seamlessly keep going on and see that we got our actor finally to work so that it does all the things it needs to do, and then get the actual game rolling. So, oh yeah, and if you have any questions, I know I said this many times before, but I can't say this enough. If you have any questions, if you're live here, just throw them in the chat. I'll definitely be having an eye on the chat. If you're watching this on YouTube, drop them down in the comments. I will be checking all the recordings of this tutorial series regular once or twice a week for comments. So if there's anything and it fits into our topics here, I will see that we get it covered here right on the show, or otherwise I will try to give you an answer on the comment. Also, once I've switched over to the view where you can actually see the interesting stuff, there is a hashtag right above me. You can also use this one. Feel free to tweet at either the hashtag above me or one of the 2 Twitter handles below me. The first one is my personal Twitter account. The second one is the Twitter account of the studio I'm working for. Feel free to tweet at either of these, whichever you like more, if you have any questions, comments, or I don't know, you just want to tell me something. So, let's see, what have we done last week? Last week we started with a pretty empty scene, and it's still quite empty, but we have this, no, this is actually the level. Let's go into our C++ classes, because we did the actor, we did it completely in C++. We didn't use any blueprint convenience, we didn't even configure the meshes that are used to display the separate states of our cell, because our actor will be, and I'm going to be showing you an example what what the end result will be, just to get it back into our memory. And our actor, that will be a cell, a living cell, like the cell on your skin or in your body or something. We did not use blueprints to just set it up and throw the meshes in there. We did everything in C++, no blueprints whatsoever. We will be using a little tiny bit of blueprints today just for convenience sake, but if you guys are super interested and really want it, at the end, when our little game actually works, as a bonus, if you want, we can port the little things we did in Blueprint over to C++ and then eventually delete the blueprints. So we'll be ending up with a project that really uses absolute 0% blueprints and 100% only solely C++. Also, for those of you, for whatever reason, can't follow up, don't want to follow up, just want to see how things are done and maybe later on take a look at it. The source code I will be doing during these live sessions together with you will be made available once we're done, when our little game works and we're happy with it. I will give you the link where you can check out the source code. So should for whatever reason you have no way of following through and coding it for yourself, you will still be able to look at the code directly, open the project up. I will give you the whole Unreal project, so you can directly open up the project in Unreal Engine. Take a look at it, play with it, and try things out. And as always, if you have any questions, even if this series is long over, feel free to ask. So here we got our C++ classes in the editor, and here's our The Game folder. I just made this so we have our own files a bit separately from the files that were created by Unreal, kind of a boilerplate. And here we got our C++ class. It clearly states, okay, this is a C++ class. There's no editor or blueprint magic or whatever to it. And we can just pull this into our scene. And let me see, we got this neat little sphere right here, because we decided that if the cell is dead, we want it to be depicted as a little, quite small sphere. And if the cell is alive, it will become a bigger cube. So that we can actually determine, is it alive, is it dead, or we can actually see the patterns that in the game will start to emerge. For now, there's not much to do with it. It just, the cell is dead, and we have actually no way of making this cell alive. And this is the first thing we're going to be doing today, because we have to have a way to set this cell to alive. Because when we have the grid of all of the dead cells, we want to set an initial state, an initial pattern. We want some cells to be alive before engaging all the processing and the generation, the calculating of the next generations, which just has nothing to do with the Star Trek show of the same name. Then the following, the next generations of our cells, because as you will see in a moment, when I show you what the end result will be, there's quite some neat things that could happen. So yeah, this is our actor. Let's throw this away for the moment. We don't really need it. What we did was, as said, we created this completely in C++, and we pretty much started with an empty file. We had a few things that Unreal filled in for us already, like the constructor, and we did pretty much almost everything except for these two things. Sorry. We did in the constructor. And what we did was we left this alone. This is something that's, if you create a new C++ class using the editor, you will always have this in the constructor, and it's a good idea to leave this alone, because if you set this to false, your actor or your component might fail to initialize at all, and then it won't work. We talked about ticks a bit in the future, so if you want to brush up on what this means and where to set it to false, check the previous episodes where we talked quite a bit about this. Then we created a root scene component, because when you create an actor, That is supposed to be, and pretty much all actors are, because if you would write code that's not supposed to be put into the scene, you would do other things like a component. So if you want an actor that can be placed in the scene and it can actually have things added, like be it a static mesh that's being displayed or rendered, so the player can actually see something, you need a root scene component. All these things that can be seen in the scene are scene components. Or for those of you who have a bit more experience with working with game engines and such, everything that has stuff like location, a transform, everything that has a transform, location, rotation, scale, is a scene component. Everything that can, with some rotation, be at some place and some size is by definition a scene component, because they are handled a bit different than just components. On a just component, a scene component, but a simple component is just code. It's just a bunch of code that you can attach to an object, an actor, or whatever else, so it can do things. So we created our root scene component. So we have this one to attach our own things to. This is just, it's simply a requirement that we fulfill here. And this is the reason I've said this quite some times already. And also as a bonus, if you guys like, we can do a mixed version of this actor. But we did this in the very first episode. We did a mixed version where we created the actual actor as a blueprint. And then we could just, everything we did here, you can just easily do in the editor, very, very convenient. And then we attached our own code that actually does the stuff we wanted it to do via a normal component onto the actor and then just called it. If you want, we can make an alternative version of this, also just for demonstration purposes, what the differences are and how things work. Because these are usually things you just do in the editor, just by pointing and clicking and selecting stuff very, very conveniently. But since we said, nah, we want to do everything in pure, solely C++, we have to do everything by ourselves, even creating the root scene component, which is the most basic requirement an actor has to be able to show up in the scene. So once we did that, we actually created our static mesh component, which again is a scene component, because the static mesh, to be able to be rendered, it has to have a transform, it has to be somewhere, it has to have a size, and it has to have some rotation, even if the rotation is 0. And since we wanted a static mesh to be displayed for our actor, so we can see it in the scene, we had to create our static mesh component. But that wasn't enough. Then we had a static mesh component, but the static mesh component had no idea what mesh actually to display, to show us, which mesh to be used for rendering. So what we did is, and I commented this is bad practice, because this is basically a hard-coded reference. For the moment, this is okay. I also explained a bit why this is bad difference or bad practice, why we shouldn't do it like this. Because if you have your artist who creates all the fancy meshes that look really nice, and you've written your code that uses those assets, those meshes, your artist usually has no chance to put his meshes, his assets he just created into your actor and have your actor use them, because your artist would need to open your C++ code to find the right place where the reference is set. Then he needs to know how to get at the reference, and then he needs to replace it, recompile the code. And there is artists who can do this. The artist I'm working with in our studio would actually totally be capable of doing this, but he shouldn't have to, because that's not the thing he's supposed to do. He's supposed to do nice and shiny stuff and not to dig around in code and change out references. So what we did is we got a reference. And how did we get this reference? When we're in the editor, And we have our assets somewhere. This is the starter content that if you create a new, fresh Unreal Engine project, you can say, okay, come on, give me all the starter content. So you get a few materials, static meshes, and basically everything you need to work with to do at least something, so you can focus completely on your code and not how to actually make things look like things. And we got our shapes, and here is the cube static mesh that we used. And if you hit the right mouse button on any asset, this doesn't only work for static meshes, this works for any asset you have in your content browser. Just hit the right mouse button, and then you got this neat copy reference. And if you do this, if you say copy reference, and then you open up a text editor and you paste in whatever it just put into the clipboard, you get this. You get this reference, which first states what kind of asset is this. It's a static mesh. And then the absolute path to where the engine can find the asset. And this is not the absolute path completely, absolute to your hard drive. This is the absolute path within the project. Which also means if you should move this asset to someplace else, this reference, well, Unreal has a way so it will still work. But if you really move the asset and you don't do it in the editor, you don't do it in the Unreal editor, you do it from the Windows Explorer or whatever, this reference will not work anymore. If you move the asset inside the editor and the engine knows, wait a sec, this thing is used. Unreal Engine has a mechanic called Redirectors, where it leaves something at the original location of the asset that tells the rest of the engine where the new location is. But that's maybe something to be talked at a different time, because this doesn't really have anything to do with C++, but how assets are handled. So yeah, this is how you actually get your reference. And going back into the code, this is what we set here. There's a special helper function that Unreal provides us that helps us to create a usable object from an asset reference to that. Then we can actually say, well, here we just save it. We take two. We have one mesh for the dead state, one for the alive state, and we save them in properties of our class. And then we got our set cell dead, which then actually tells the static mesh component, like, look, dear static mesh component, I got a usable object. This is what we save here. This one. This is the usable object created by the helper function up there that we just remember. So later on, when we need it again, we can just reuse it and don't always have to fetch the mesh again, because as you can imagine, that would be a kind of strain on performance. And because we want to do this from different places, we don't only want to set the cell to a dead state at this single spot. We want to do it at different places later on. We made a convenient function we can just call that takes care of everything that needs to be done to set the cell or our actor to the desired state. And we got two of these. We got one for alive and one for dead, and we're calling the dead one, which at the moment only tells the static mesh component, look, here I have this little handy object that's actually a static mesh. Please do use this one to render the mesh for the static mesh component. Each static mesh component holds one mesh that's supposed to be rendered. So you can do an actor that's composed of several individual static meshes, no problem. You just have to create one static mesh component for each of the meshes you want to use for your actor, then assign the meshes to the components. And maybe, and this is one thing we'll definitely be doing today, set the position. If they're not properly aligned already, I think I need to moisturize my throat a bit. Yeah, so you need to set the location of the meshes, which is something we will do. We will set the location and the scale of our meshes, because for reasons we are about to discover. So, cheers. Oh yeah, that's good. Moist and cold. So yeah, that's basically, well, that's almost everything we did. All we did up to this point was create all the scene components we needed using our additional function. We told our static mesh component which static mesh it's supposed to display. And then we still needed to attach our static mesh component onto our root component. Remember, at the beginning, I said we need the root scene component so we can then attach other things we want to have at our actor to it, which is what we're doing here. We are then telling our static mesh component, look, please set up your attachment to this one, which is our root component, because you can also you can have the hierarchy like whatever you want. You can set up a static mesh component as a child of another static mesh component, if for sorting or ordering, or just so it makes more sense when you look in the editor how things are set up. And since we only have the root component, we just tell our static mesh component to attach itself to that. And the result was that we have a neat little C++ class we can drag into the editor and see something. So just a very, very little reminder for those of you who weren't here last week but still want to know what we're going to do, what's the goal we're trying to achieve. A little demonstration of what we're actually trying to build at the moment. For those of you who haven't heard about Conway's Game of Life, you have a grid. Consider this like your math sheet paper, just a two-dimensional grid. And all these little dots are dead cells. You could just depict them by nothing, by an empty square, but since we need something to click on to make them come alive, I decided we make them these little tiny spheres. And we can even move in a bit so we can actually see they are tiny little spheres. Move out a bit so we can actually see everything. And then we can click on them. And then they become these huge cubes, because these cells are alive, and we can do several of them because those are pretty neat parents. And then we do one of these. Some people call them gliders, some call them movers, some call them spaceships. What the Game of Life then does is, each cell, there's a set of 4 rules. And these rules define, and we actually have to take a closer look at these rules again today, because we're going to be implementing those rules. And there's 4 very, very simple rules that define if in the next generation, this is the current generation of our cells. All the dead cells are dead and all the alive cells are alive. In the next generation, some cells might be dead, and some that used to be dead will come to life. And there's 4 very simple rules that define this behavior, which cells lives and which cells die. So when it calculates this, it calculates for every cell for the next generation, is it alive or dead, and then it just displays it. So, and we can start this, and if we do this, this is exactly what happens. The game now runs kind of in an infinite loop and calculates the next generation over and over and over and over, and then sets all the cells to their respected state. And these little guys, some call them oscillators, some call them blinkers. I like to call them blinkers because they're blinking, flopping between 2 states. They're kind of stable. They just sit there, do their thing. But this one, you've seen it crawled down till the grid was over, and it became this little cube, which is kind of stable and just sits there. So this is what we're actually wanting to build. So let's dive back into it. The first thing we need to do, because right now all our actor, our cell, can do is sit there and be dead. Now, well, we don't want that, as you just saw. We need to be able to click on it and make it come alive. We already have code that makes our cell alive because we have this set cell alive, which for the moment is nothing more than swapping out the mesh, the static mesh component displays, because you can do this. You can, at any time you want, you can tell the static mesh component to just display or use another mesh to render, and then your actual looks completely different. So we got this set cell alive, and as I said, for the moment it doesn't do much more than just telling our static mesh component to use our alive mesh. Now, how do we make this clickable? It's actually pretty easy because that's kind of the point of using a game engine. Unreal offers us quite some neat and handy functionality that pretty much takes care of these things already. There's events in Unreal. There's a lot of it's a lot of stuff is event driven. You got events fired for all sorts of things. You can create your own events and fire them at your will. And there's one event that can happen on an actor, which is on clicked. And there's my autocorrection, which also neatly presents me this one. And then we can tell it what it's supposed to be doing. When this is an event. And now we have to tell this event we are interested in you. We are interested in this event. We want something. We want to know that this event is happening. And we can do this. There's quite some options you have. Can I scroll? Yeah, I can scroll this. There's quite a few things you can do. Quite a few things you can check. If you're super interested in this, feel free to check out the Unreal Engine documentation. It's okay-ish. It leaves quite a few questions open sometimes, but these are usually then answered on places like Stack Overflow or such. What we need is we don't want to broadcast something. Broadcast is the other way around. When you're triggering the event, you want to broadcast this away so everybody else who's bound to this event then knows what to do. And you can do so much more things, is bound and remove everything, and we don't think we need this. But we want to add our interest to this event. So let's check the tooltip up here, and we need a delegate. Okay, we can't just give this a function. If we try to give this our set cell alive, well, my IDE already tells me, nah, this doesn't work because we need a delegate. We can do that, no problem there. So we have again a custom type that Unreal offers us just to use. We got a script delegate. There it is. I'm always hoping the autocompletion to support me in a way where I actually specifically find what I'm looking for. And one thing I'm looking for is my chat. Just lost my chat there for a second. So we got our delegate. A quick peek into the chat if everything happened, but everything seems to be in order. That's good. So we need a delegate. We just call this because I'm so great and creative in finding names for my variables. I'll just be calling this delegate. So, and there's another thing. I'm doing this right here at the moment because right here we noticed how we need a delegate, but there's another thing that you don't have to do, but I personally, and this is kind of personal preference, and you have to talk about this in the team you're working with. If you're working in a team, if you're working for yourself, you can do whatever you want. But I personally find it's good practice and not too uncommon in C actually, that you have all your declarations, all your variables. You eventually going to be using, you declare them at the very top of your function. And I will be changing this in a bit. But for now, just so we know what we're doing and what we're dealing with, we declare a new variable of the type f script delegate, and we just call this delegate because we're so creative. And this one again offers us some nice functionality that we can just use. And one of them is, this looks good, bind EU function. Bind EU function, because remember what I've said in the past few episodes. Every time, for everything, there is a Unreal specific type. We're not using any of the default types C++ as a language offers us, maybe with the exception of floats. And we're not even using plain integers. There's int32 or int64. You have to use these instead of plain int. Float, we basically just use the normal float, but that's about it. For pretty much everything, especially strings or the such, or even arrays, Unreal has a specific type that's tailored to work best with the engine, so we always use those. So we don't just use an array in C++, we use a, I'm not sure if it's called T array or F array, something like that, might be T array. Or we can just have a quick check. I think it's T array. Which is Unreal Engine's version of an array. But most of the times I'm using maps, and we're also going to be using a map here today because they are just way more convenient and super duper for us. So what did we want to do? So this is why there's a U function and not just bind your function. It has to be a U function. And our function is set cell alive. And this is, okay, this is completely wrong. Maybe I should, what does it tell me? What does the autocompletion tell me? I think I know what it's going to tell me, but it's telling me that we need a reference to the object from where it's called, which needs to be a U object, and then just the function name. All right, we can do this. The object is obviously this one because we want to call our function from our actor. You can also have something else called. If you have another object that handles all your actual work and you want, when the actor is clicked, you want your other object, your other code to do something, you can also have it called from your other object. You just have to give the reference to the object from where a method is called, which in this case is just this, and then basically only the name of the function, which is set cell alive. And now we got our delegate, and we can pass this to the onClicked add. And what we've done now is we've created our delegate. Let's put a neat little comment on here. Create delegate that is supposed to handle when we're clicked. Click event. So I think this should be pretty clear. Maybe if why did I put these east there? So we create a delegate that's supposed to handle when we're clicked, and then bind our delegate on the actual onClicked event supplied by the engine. Well, actually, it's part. I'll leave this out. It's part of the actor base class. Remember, we're just not doing a class completely from scratch. We're extending the A-actor class and inheriting everything the A-actor class has to offer, which is quite a lot. If you want, peek into the header for the A-actor class. I think we did this last week. There's quite a lot going on there. And the unclicked event is one of the things that's in the A actor class. And since we're extending from that, we're inheriting everything. We also have this. Again, if I have no idea how much foreknowledge you guys have about coding in general or object-oriented programming. If you need like an explanation or a brush up on how object-oriented programming works, what's inheritance, what's extending a class, what does this mean, what does this do, please just let me know. I'll be more than happy to talk about that and explain and tell you all these nice things. Oh, Fire Splash! Hi! Greetings go out! Didn't see you there because I had my chat covered up by other things. Nice for you to stop by. Hi there. So, you wanna switch to Unreal? This is why you're watching Unreal tutorials. Maze Crusher 2 will be done in Unreal Engine. So, we got our delegate. We got it bound to the event. So if we compile this now, it should compile fine. So we hit the little bar cube up there. I have everything compiled. And we should be able to click on our cell and it will come alive. Or in other words, this sphere will become a cube. So we pull this in here and we hit the play button and come a bit closer. Oh, and look at that. I can't click it. Because with the default player controller, it's default. That's just there if you haven't done anything customized on your own. You're able to look around and you're able to move, but well, you don't have a mouse pointer to click anything. So we need to do something about that. So we can actually click our little sphere there and let's get this a bit closer to the player start so we don't have to move that much, because I'm lazy. I don't like to have to move around a lot when I just can. Yeah, this works. I think this maybe a bit closer. Well, this is, yeah, maybe like so. Okay, this is cool. So now we just need a way to be able to click on this. And for this, we need a custom player controller. Because in the player controller, we can tell Unreal Engine, look, we do want to support mouse events, so we do need a mouse pointer. And for convenience sake, we'll just be doing this as a blueprint for now. This is the thing which at the beginning where I said we're using a bit blueprints for convenience, because it would take significantly longer to do this in C++. But if you guys super duper want it, at the end, when everything works as a bonus, we can port these things over to C++ and delete the blueprints, so we will be ending up with 0% blueprinting. But for now, we just make here's player controller, and we call this blueprint our player controller. And there's an old actor that says about to be deleted, so let's do this. Let's just get rid of this so it doesn't confuse us. Okay, I made a core folder because for the core main basic things, so we can just move this in there. I'm not sure if it even left a redirector like I mentioned a bit earlier. Let me see. Other filters, show redirectors. Yeah, there's none because it wasn't used yet. So everything's fair. And then we open this up. And here we go. This is what we're looking for. this is the blueprint of our player controller. We could do super duper blueprint magic in here. We'll add a tiny little bit here later on, but for now we don't need anything. So this is basically, yeah, player. You don't really see the player controller, even though it has a camera handle here, but usually the camera is handled by the palm. You can do this, in the end you can do this whatever suits your project more. But we don't have to deal with this at the moment. We leave most things as they are per default. But here, in the properties of the player controller, there's one thing that's of interest to us, which is the mouse interface. Here is the mouse interface, and we do want show mouse. Exactly, that was exactly our problem. We couldn't click on anything because you need a mouse pointer to click on things. So we do want the mouse pointer to be shown. We also need to enable click events. Just having the mouse pointer won't yield you anything if click events are not enabled. You have to explicitly enable or not enable them. And yes, we do want that. So that should be enough, but for good measure, I'd say we enable mouse over and touch events. Oh yeah, mouse over events are nice because you can. There are more events, of course, like just on click. There's also on hovered in, on hovered out. The names might be a bit different, but that's basically what it is. There's events for when the mouse moves over your actor, and when it moves away from your actor, when it's not on top of your actor again. There's another event. You can react to these, and in our actual project we do at work, we actually use these because you got all your game tiles, and the one the mouse is currently hovering is selected and everything. So this we need show mouse cursor, and we need to enable all those mouse events. And again, sorry, cheers. It's the weather. It's been like 35 degrees for the last over a week. And today it started to rain. But really, half of the day it was raining, which did actually get some cooling down of the temperatures. But now the moisture in the air is 80-90% or something. So need some more water. So my throat actually is on the same level in the air. Yeah, might help against those coughs. So yeah, we got all the mouse thingies enabled there, so we can compile and save this. But this doesn't really help us because now we created drink more water. Well, I am. I got my water here. I got water in reserve, which really looks refreshing because the bottle is straight from the fridge, and my fridge is set to 4 out of 5, so it's quite cold. And with the immense humidity in the air at the moment, the bottle itself collects quite some water on the outside, which I don't know, looks quite refreshing. So yeah, back to topic. We got our player controller, but we need to tell the engine to use our player controller. Just because we have our player controller doesn't mean anything. We have to tell the engine that we want to use this player controller, and we do this in a custom game mode. So again, for convenience, we create game mode. I think it's game mode. Yeah, it's game mode. But there's two different things you can. You can extend its game mode base and game mode. I think we do need the game mode base, and we call this. The difference is the game mode base is really just the basic game mode with the minimal things you need for a game mode to work, and the game mode without the base has additional stuff added in that's usually more for first-person games, which we're not really doing. So we call this BP our game mode, and if we open up this one, we can see here there's a classes section, And we can set quite a lot of things here. We can game session, game state, player controller, player state, yada, 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 yada. Game state, by the way, something we'll be using for this project. Game state is something we'll be using. But for now, we made our player controller. So click on that, and here it already is. BP, our player controller. This basically lists all the player controllers. It's filtered for the plopper. Gonna practice a bit more talking. It's filtered by the proper base classes. The other classes are extending from. So there's only five items, 5 classes here. And one is our BP, our player controller. So we're just going to be using this. Compile and save. And this is still not it, but almost. Now we got a game mode that has set our own player controller as a player controller. Now we need to use this game mode, which is even more easy. We just go into our project settings, and maps and modes. Always, the list is so long, I always have to look for the things. So maps and modes, and here, default game mode. There it is. I'm not sure if you can see it. Let me magnify this a bit again. Default game mode is the basic game mode base. And we just set this to our game mode. And that's it. Close the properties. And now we should have completed the whole chain. We have our own player controller that has mouse control enabled. We set this player controller as the one to be used in our game mode. And we've set our game mode to be used by default for our game. And now you can see when I click into the area here, I can already look around while I hold the mouse button clicked. So if I hold my mouse button, I can still look around like I used to. But if I don't hold my mouse button, I can actually use the mouse, and I should be able to click on our actor and nothing happens. This is interesting. This is usually the part, if you only create for YouTube and it's not live, you would cut. Nothing happens. And we have to find out why. So, first of all, let's go into our code. And what did we set? The set cell alive. Let's do something else. No, that's not. Let's just add a log output, and for the life of me I can't remember the syntax, so I'll be copy pasting this from someplace else. So this is our cell actor set alive. So this is basically this is only a log output. This is only supposed to print a message down here into this logging window. So, yeah, and I made it a warning so we can actually see it. It pops up in yellow, so we can actually see that something's happening, because, I don't know, maybe this is not working. Maybe it's not called at all. I think it's not called at all, for whatever reason. There might be quite some, so let's delete this again, because I have one idea why this isn't working. And if it's working now, I will tell you what my idea was, because then it might have been it. So get this back in here, hit play, click on it, no, and still nothing happening. This is kind of disappointing, because it actually should have worked. There's one more desperate thing to try. I'm not really sure it will help in this case, but sometimes it does. And then maybe let's check these things. Let's check our blueprints just one more. We got the player controller. Wait. where's my, oh, here's the mouse there. Okay, because it's, the editor noticed that there's nothing on the event graph or such, so it went into a smaller, more compact. If we open the full editor, we get this view again. And here's our mouse thingies, and we show the mouse cursor, enable click events. This is looking good. Left mouse button is one of the, well, and it did work. I mean, basically we don't need to check this because it did work. I mean, I do have my mouse pointer. I can look around. It's just the click event isn't working. This is interesting. Maybe our C++ class wasn't properly reloaded. So this is one last desperate attempt of maybe getting this to work without having done anything wrong. In the meantime, we can check our code again. We created the delegate. Set cell, maybe we got a typo here. Bind U function on click add. I'm gonna check if maybe we did something wrong there, or maybe we're missing something else. Well, let's see. Just reopening the editor, and maybe it'll work. No, this is wrong. There's the maps. Load our map. Drop our actor in there, and it still doesn't work. Okay. So we are still missing something. And I'm actually wondering what. So let me check my notes quickly. If there's maybe something I was missing. So what did we do? This is always super interesting. You're doing a tutorial and you guys are expecting to see how things are done, and then nothing works. So we got our delegate. We create a bind U function. This and the cell alive. Oh, maybe, wait. Is it maybe because it's private? Let's try this. It could actually be because when I tried this out, let me just double check on this quickly. When I tried this out, the function I used for my delegate was a public one. So let's try this. Maybe this is actually what went wrong. Let's create. We're gonna be needing it anyway. So, and why do I keep getting the wrong window in the front? So let's copy paste this because I'm lazy. Let's have a on clicked. Well, maybe not, because we already got this here. Let's just call this clicked. I would have liked to call this on click because this is our event handling thing, but we already got a on clicked in this class. So let's just call this clicked, and let's move this log entry to here. And of course, we need our it also defined in the header function. Currently, there's not. And we just say create declaration. Now we got the declaration somewhere here. There it is, on clicked. And oh, there's another reason why this might have been a combination of both. But remember when this is bind U function. Maybe I stepped exactly into this trap. Remember what I told you about U function, unroot types. Let's declare this as a U function, and for not law but order, This is a property. Let's have them at the top. This is just a personal thing. I personally like it when first there's all the properties that are in this case public, or in this case private. This is a better example because there I got some. First I got all the properties, and then I got all my function declarations. This is just me. This is basically, you really can do this like however you want. You can even have them completely unordered, but I find it hard to find. Even if your classes grow larger, you start having a hard time actually finding things. So we got our clicked function. We got it declared as a U function, which is good. And it's public, so it actually can be called from the outside. So, why is this underlined? Well, I don't care. So actually, let's change our delegate. So it's using our click function. Save everything. Back into the editor. Delete this one so we get a fresh one once we've compiled, and do exactly that. Compile. Because this is something that happened the last few times when you got an instance of your class in the scene and you compile it. Your instance that's already in the scene will not be updated unless you completely close and restart the editor, because then it has to reinstantiate it. And this is also something. This is why I also try to restart the editor. This is something that might happen to you. You change something, you recompile, and it doesn't work because you still have an instance of the old version in your scene. You need to delete it and just drag it freshly into the scene. So Unreal creates a new instance based on the current version. And now let's try and yeah, see, this is it. It still doesn't change because we haven't done this yet, but look at the log here. We're going to be clearing the log, and if I click here, maybe you can hear it, I'm clicking, nothing happens. But when I click on our actor, I get this log entry that tells me, yeah, here, cell actor. Oh, and I didn't paste, I pasted the name right into it instead of properly replacing this part. Let me do that. So this looks better. So now we can call our set alive. And if we compile this now, stop and compile. Now our cell should actually change. So yeah, I'm not 100% sure if it was the public, and I'm too lazy to try out. If you're trying this, if you're working alongside me, and you're trying this for yourself, try putting the clicked function into private, see if it still works. But definitely the U function was missing, because I mean, we literally got told that we have to bind a U function and not just some random function that exists somewhere in the world of your C++ classes. So that was definitely a thing that was missing. Let's blame the weather. Let's say it's just too warm to think straight, and that's why I missed it. Cheers. All right, but now it works. We're cell active. Did we compile it already? Yes, I think so. So let's start this. Let's get a bit closer. And when we now click our actor, yeah, see? It becomes a square. And if we move a bit, we can actually see it's not just a square. It's actually just a nice cube. So let's do this. Let's move a bit up and to the side. And when I now click on the sphere, we're getting a nice cube. But when I click again, nothing changes. Because, of course, we just told it, when I click it, to set it alive. And now it's alive, and we're clicking it, it still wants, or it still does set it to alive. So we need to put a toggle in there. This is my code, right? And this is why I said we need a clicked function anyways, because we have to check if this, because I want the click on the actor, I want it to toggle the state. So if you click onto the cell or actor while it's alive, I want it to die. And if it's dead and you click on it, I want it to become alive. So we need to keep track of in which state we are. And of course, we could check what's the current mesh that's being displayed. But that's pretty, I'm tempted to say meshy, but I mean messy. But you get the pun I'm aiming at, but it doesn't work. So it'll be messy if we check the current mesh that's being displayed. So what we're going to do is we introduce a new private variable that's a bool, and we call this is alive. And at first, no, not at first, we can just here in our set alive, we just say is alive is true, because when we set it to alive, it is. And I'm so lazy, I'm even copy pasting this. And when we set the cell to dead, well, it's not alive. So is alive will be false. This is also why I find for chatbots, it's pretty funny. You know, in chatbots, you usually have the commands always start with an exclamation point command, and then the bot does something. That's always why I find exclamation point false. That makes the bot respond with true. It's always a funny command to have. Yeah, just saying. So we have our variable, we are properly setting it, and now we simply need to act on it. So why is this indented completely wrong? What is, no, it's right, okay. So if we are alive, maybe without typos, like so, if we are alive, well, we set ourselves to, and auto completion is leaving me in the open. Here, set cell dead. If we're alive, we'll set ourselves to be dead. And in the other case, and there is only one other case, so if we're not alive, we're dead. So what we'll be doing is we're setting ourselves to alive. Save and compile and try. There is no try. There's only do or don't. Well, in this case, we do try it. Deal with it. There's the guy with his sunglasses. Nice, I'm still having this emote because these modified emotes are only valid for 24 hours, and I got it, yeah, pretty much yesterday around this time. So happy to still have it. Or maybe it didn't even work for you anymore, I don't know. So did we compile? Yes. Did we refresh our instance of our actor? No. Now we have. And if I start this and we get a little bit closer, even a bit more, and when I click the little actor, it becomes alive. Okay, we had it so far, and I click it again, it's dead again. Look at this. Now I can toggle my actor between it's dead, it's alive, it's dead, it's alive. But I also wanted, remember the little sample I showed you, because at the moment the sphere and the cube have the same size, but to be better able to determine if you have the whole grid full of these things, in my opinion, it's a bit more easy to see if the cell is dead or alive if the sphere is quite a bit smaller. So let's see if we can make the sphere smaller than the cube. So let's go back here, and if we set the cell to dead, which also sets the static mesh. And let me cheat a bit by looking up the exact names of the functions we need to call. We're telling the static mesh component we want to use our dead mesh, but there's so much more we can tell it. Static mesh component, and we can also set, we can set so many things. And the thing I'm looking for is not listed at the top. So let's look if there's something about scale. And if I don't mistype it, maybe I actually find it. Bound scale, mask scale, something scale, relative scale. Look at that. Relative scale. And the online help function tells us set the non-uniform scale of the component. And here comes the important part, relative to its parent. So whatever we tell it here, it's not in relation to the world space. It's always in relation to our parent. So if we scale down our parent, if we scale down the whole actor, maybe we could do this. Wait, we can just do this. Let's go into the editor, and this is our actor, and it currently has a scale of 1 in all axes, and let's just use the lock. So this means if I close this lock, these are bound together. If I change one of these values, all the other two, whichever they are, they change with it. So if you want all axes to be the same value, you can just use the lock, and you don't have to actually set all three values manually to the same value. So if I scale this down to, I don't know, 0.5, I'm scaling, this is our actor. Yeah, this is our actor I'm scaling. This is not the mesh inside the actor. But since the scale of the mesh is relative to its parent, which is our actor, if I scale down the actor, the mesh itself still has a scale of 1 or 100%. In relation to our actor. But since our actor is smaller, 100% of a smaller actor is a smaller mesh. So while I scale this up and down and maybe even up, the mesh scales with the actor. I could set the scaling on our actor, but I'm not going to be doing this. I'm just going to be setting the scale on our static mesh. So our actor itself will remain a scale of exactly 1. There won't be scaled anything. But the mesh inside our unscaled actor, that one, will become smaller. And this is the difference. This is why can I find it again? Relative scale, yes, here. This is why this is the relative scale. I'm not sure if there was an absolute thingy, and got a feeling I deleted too much. No, I didn't. Well, anyway. Set scale. Oh yeah, set world scale. The relative scale of the component to specify scale width. This basically sets the scale of the mesh in relation to the world space. So if you set it to 1, it appears in the size the mesh was actually modeled in. Well, it recalculates the relative size for the actor. It's 3D math stuff. There's quite a lot going on. So we want the relative scale. And the relative scale is an F vector. And there's a very convenient way to just add one. We just say F vector and give it the values we want. And in the dead state, I would say put it to 125 Fahrenheit. Or maybe float value. So, for all three axes. I think that should do it. And then we just copy paste this to our cell alive. Because if we set the scale by setting the dead scale, dead state, Jesus Christ, so many words to be confused. If we set the scale when setting our cell to the dead state, the scale will just stay no matter what we do. Even if we set the alive state, why should the scale change unless we intentionally do it, which is actually exactly what we're going to do in here. We just be setting the scale back to 1. So our mesh has its original size when, well, in relation to our actor. All right. Let's try this. This, I think, is this the right one? Oh, I think no, this is the right one. No, everything's okay. I'm just confusing. I got a few windows too much open here. So let's compile this. And put our actor back in, and it's already, you can already see it's kind of small. It's kind of tiny, and if we select it, there it is. We can see our actor still has a scale of 1, but if we pick out our static mesh component here, we can see, oh, can you see it? Our static mesh component now has a scale of 0.25, so 1/4 of its original size. So let's click on it, and we got a huge cube. And again, if we check the scale of our static mesh component, there's the static mesh component selected, we got a scale of 1, click on it again, and we got a scale of 0.25 again. So now there's one thing, I'm not sure if you noticed it. Let me see to get pretty much directly in front of our actor, because there's still one thing that bothers me a bit and also gives me a good opportunity to show you how to set positions, because you see they are not centered. The sphere is sitting down here. Where's the going down button? There. The sphere is sitting down here, and if I click on it, they share as the common center point, as the 0 coordinate. They basically share the ground down here. That is because those meshes are created in a way so their 0 coordinate is actually down here. Usually, or quite often, well, depends on what kind of artist you work with, but quite often you have the 0, 0, 0 coordinate somewhere here in the 3-dimensional center of everything. But these meshes are made in a way so if we look at it from the top, you can see it's actually a bit more centered. Oh, der Reichardt! Hello there! Greetings! A wonderful Thursday evening. Hi. Dokumentierer-Gruß geht raus. Hi there. So you can see it's a bit centered when you look from the top, but it's absolutely not centered when you look from the front, which bothers me a bit. I find this a bit more neat when we have the grid of all our cells, and these meshes are actually centered in relation to each other. So this gives me a perfect excuse to show you not only how to set the scale of something, but also how to set the position. And I think most of you might already have an idea. If you can say set relative scale, we could also just say setting mesh component set relative location, which is the location relative to the actor. This is, again, this is why this relative is quite important. Whichever coordinates I'm giving it here, they will be relative to our actor, not the world. So, which is this? This is the alive cell. Let's just say this to 0 3 times, because we live in a 3D world. So So now I'll be telling my static mesh component, look, please be at the 0, 0, 0 coordinate, which is, well, yeah, the coordinate origin for all your mathematicians out there. But this, again, this is relative to our actor. So this is not the coordinate origin in our world space. So it won't be sitting at the center of our map. It will basically be sitting exactly where the actor is. So whatever the position of our actor, of our cell in the scene is, will be exactly the position where this, our alive static mesh, will be shown. And for the dead state, let me just peek into my chat quickly. So we of course do this again. Static mesh component set relative. There was. You can, of course, if you say, nah, dude, I have a use case where actually, no matter where my actor is, I want this mesh for whatever reason, but for me it makes totally sense to have this mesh at a specific location in the world. I don't care where the actor is, but if the actor moves, all your meshes move with it. So usually this won't make sense, but maybe in your case it will. So of course, location, and now just be gentle with the keyboard and only hit the right keys. You can set the world location. So if you want your mesh to be at a specific location, the mesh that belongs to your actor, to be at a specific location in your scene, in the world, you can do this. But be aware, it's still bound to your actor. So even if you set the world location, this basically only translates it to what would be the relative location required to have your mesh showing up at this specific position, this specific point in the world. So even if you set the world location, when your actor moves, the mesh moves with it. It doesn't stay at this specific location. So this is some quite important distinction, and might cause some confusion at the beginning. And yeah, this is our dead state. This is the little sphere. And remember, the 0 point is at the bottom. So the problem is I can't just set this to whatever the center is, because it's a bit offset. The Discord link. That's a good question. Is there a bot command for the... I should know this. Worst case scenario, the link to the Discord is on the website. Unfortunately, I don't have a direct link at hand, but I will see to be more prepared the next time. Lakeside's already on the job. Thank you. Thanks a lot. Lakeside will see that you'll be getting your Discord invite URL. Can we have Discord server that we can follow and notice? Yes, we do. There is a Devcom Discord server, absolutely, and you're more than welcome if you have any questions to ask. But also, just let me quickly point you to the hashtag up there and the Twitter handles down there. You can also tweet to those if you have any questions. If you have any questions, like later on when you're watching the recording of this and you can't just ask your questions in the chat, you can also use this, tweet either the hashtag or the Twitter handles below with your questions. Or if you're watching this on YouTube in the recording, just put them down in the comments and I will be making sure to check them out regularly. So that we can either get your questions covered and answered right here, or we'll see that I get your response. by, I don't know, just replying or something. All right, so we need to set a position. And the position is, because I've tried this out before, I know that we need those two axes to be 0. We don't need to change them. And now there's some weird magic. We want it to be at the middle, which is 50% of. But I don't. Wait. Just believe me. You've seen the cube and the sphere have the same size, so I actually can work in percentages, because if I say 50% of the square, which is also 50% of the sphere. So I want this to be at 50%, and this is just some neat little math tricks that I'm using for ages to quickly calculate where something is supposed to be, if it's supposed to be at the center of something else. So we want it to be 50% of its original position, due to in which direction the axis in Unreal Engine we now have to subtract something, because remember, the 0 point is not in the middle. This would already be perfectly fine if the 0 point, the 0, 0, 0 coordinate would be perfectly in the middle of the sphere. This would already be it. Case closed. But it isn't. It's at the bottom. So we have to offset the position where we actually want to have it by half of the height. Does that make any sense? I hope. Because look, this is the area where I want it to be, and this is the thing I want to fit in there. If I set it to 50, I have it here. But I actually want it like here, so it's perfectly in the middle. So I have to move it down by half of the size of itself. So let me just quickly copy paste this into it, which is its current size divided by 2, because it's the half. This should do it. This should place it pretty neatly at the center of the cube in all 3 directions. Let's compile and try. And then do something more interesting. So, place this here. I don't know, closer. So, oh, this is still quite far away. So if this looks way better already. Let's see if I get a placement where I'm pretty much right in front of it. So here's our player start. Here's my actor. And we could just set this, you know what, let's just set this to 0, 0, 0 by hand and fly a bit towards it. So, if everything perfectly works, I should now be getting a cube that's somewhere around here, and doesn't that look nice? Look at that. It's perfectly centered. The sphere is perfectly in the center of our cube. And if we do this from above, it's still neatly centered. So from wherever we look, let's try to get a more interesting perspective maybe. Like so. So wherever we look, the sphere now shows up perfectly centered in relation to our cube. Nice. So here we got our base actor. This is our cell that we can toggle and set if we want to have it dead or alive. Because remember, we have to set the very first, the Genesis generation, we have to set ourselves. We set the neat little parents that will then be calculated by our game logic. So yeah, why not? Let's get started on that one. Because now that we have this actor, let's do something with it. Because one thing we could do, and I promise you, this will get very tedious very quickly, and also it's not really flexible. I could just drag in a lot of these thingies and make up my own grid, and then I can hit play, and you can see they are already not very well positioned. Yeah, but I can set them. But for one, this doesn't look nice. You really have to take care that they are properly positioned. And if you want to make quite a lot of them, let's just imagine a 10 by 10 grid of cells. It's already 100 actors you have to drag into the scene by hand. I've said this again. Computer people usually are super lazy. They don't do that. That's why we have computers. We have them to do it for us. And look at that. There's also all the links you need. Nice! Thanks a lot for that. So, what do? We create a new C++ class, because now we want something that's not part of our actor. Our actor needs to be placed in the world, in the game world, in our map. Well, it's not really a map, it's pretty empty, but technically it's a map. Our actor needs to be placed in the world, and it also needs to be placed as many times as we want, because maybe we just want a little 10 by 10 grid, but maybe we want a large 100 by 100, or maybe even 10,000 by 10,000 grid. But I tell you, the last one will take a hit on your performance. And there's also the tick thing. We could, there's a little nice opportunity to show you the actual effect on performance when you have the tick enabled or not. Remember, we talked the last few weeks, we talked about this a lot, having the tick enabled of your components and your actors. There's actually a pretty neat opportunity to show you that. So now we want a piece of code that deals with placing our actors where they are supposed to be. So let's make a component for this. Let's make is it an actor component? I think it's an actor component, yes. Let me just quickly check at my cheat sheet, and we're inheriting from actor component, yes. So, and it's also, I think I already mentioned this when I did the actor, is also good practice to suffix whatever class you make with what it is. So when we made an actor, we called it cell actor, because it's an actor, that's our cell. So when we now create a component, we keep the component suffix. So when you're looking through all the files, you already have a basic idea of what they are. So let's call this, I don't know, game grid component or a field handler. Let's call this field handler component, because this thing handles our field of cells we're going to be playing with, and we're putting this in the game folder, and Unreal is creating a few files for us. Great. So while that is running, quick peek into the chat. And let's see. So the first thing is, the very first thing we always do, we clean up a bit. We delete all these default comments, because by now we've seen them so often, we pretty much know what they're doing. So just get rid of them so things get a bit more tidied up. Also, oh, this is quite long with this font size. Here's a public block, there's a public block. I don't need several of them. For me, it's totally okay to have only one. So we make this private already, so in case we have any private properties or functions, we can put them in there. So that looks neat and tidy. This is the default stuff. We've seen this many times already. We've talked about this many times already. This is the default stuff that Unreal creates for us. And we'll just be going ahead with creating a new function. And we want something that sets up our field. Remember, now we have our actor, and we need or want a huge field. We want something. We want I don't know, 10 by 10, 10 by 20, 13 by 35, 42 by 100, 1000 by 1000. We want to have a field, a grid full of actors that we can click on to make them alive, to then, in the final step, have our game logic constantly calculating the next generation to show us if the cells survive, if they die, if they come to life, or whatever. So I will call this init field. You can call this whatever you want. Let your creativity flow how you want to call this. I just be okay with this. So, and we want it to be flexible. I told you already when we put these references to our meshes in there, I'm not a huge fan of hard-coded things, because that makes stuff quite unflexible, and you always have to dive into your code and recompile just because you want the field not 10 by 10 but 100 by 100. So let's have some parameters like our size in the X direction and our size in the Y direction. And what's this? Okay, this needs to go. And also we want to be able to tell our function how to space, how much distance to put between the actors that it places, because maybe you have set up your actors with a different mesh that have a different size, or maybe you change the meshes. Because again, one thing we could do as a bonus is to make this actually be configurable from, I don't know, maybe we come up with a neat place where we can set this up. So we have a cell distance. And also let's have parameters for where to put it. Because maybe, I don't know, maybe you're implementing this and this is a horrible typo. Let me just fix this. Distance. So, not resistance, only the distance. Maybe for whatever reason you need the grid or our field of cells to be someplace else because you build a nice surrounding. Maybe you really build a nice surrounding scene, and just having it at the 0, 0, 0 coordinate doesn't work because your scene is set up differently. So also let's have a parameter for the base location on the x-axis and a base location for the y-axis. And I have no idea why I keep hitting the wrong keys. So base location x, base location y, cell distance, and all those sizes. All right. Nico, hello to Argentina. Hi. Nice for you to stop by. Sit down, relax, and I actually need to refill my water here. So, oh, Modern Genesis. Hi. This bottle, just by being cold and just because the humidity is so high, this collected so much water on the outside. I could almost shower again with it. And I've just showered, so I don't need that. Well, anyways, cheers. Yes, and we're back on it. After after some talk about unrelated things, just because, I don't know, sometimes that comes up. We're back on track. And we're already, for those of you who just stop by, we already have our actor. Let me run this again and move to it. Which is a tiny little sphere when it's dead, and now we can click on it, and we have a huge little cube that tells us this cell is alive, and we can, each time we click on it, it just toggles state between dead and alive. Unfortunately, these are only spheres and boxes. If this would be a cat, then we could have a third state, dead and alive at the same time. But since these are only spheres and cubes, we can only choose between them. Those are our cells, right? Exactly. These will be our cells that then later when the game runs will either be dead or they will be alive. And since we have to set our initial state, we want to put in some neat little patterns and see how they evolve. We need a way to set them to whatever we want them. So now we already can just click on it and toggle between those states. So let's throw this out. And what we just started doing is creating a function to actually set up our field. Because what we could do, but I already said this will be very, very tedious and will get very boring very quickly if we just pull, even for a 10 by 10 field, which doesn't sound much, you'd have to pull 100 actors into the scene, properly place them so their placement, the locations are not off and they are not going up and down and stuff, which becomes very tedious. So we're going to be doing this by code. We're just going to be placing there wherever we want. And there's one thing we can, a quick fix, because I told you I'm a huge fan of having variable declarations at the very top. So let's just do this. Let's move this one up here. So we declare our delegate variable up here. So way down at the bottom here, we can just use anything else we need to move. This is a bit hard because this is not just a declaration. This is already calling a typed helper. So let's just keep this there. This would actually make it even more confusing putting this at the top, but I think this looks nice and tidy. So let's go back into our field handler. Quick peek into the chat, because there always has to be time for the chat, right? So, because now I just came to this because now we're going to be using quite some variables. We're going to be doing quite a lot, and there's two very, very common. It might be the classics under the variable names, because obviously we have a size X, how many cells we want besides each other, and then we have a size Y, how many rows, how many columns of cells we want and how many rows of cells we want. So obviously we're going to be looping through those. We're going to do a loop, or two loops actually. So you're going to be starting by 0 and then counting up to the requested number of cells for our field. So we need an I, and I already know we also need a J, because we could use I1, I2, but I just call the second one J. It's a bit more easy, because we're going to be looping through the X and the Y size. So let's do this. So we'll be starting off with, what happened there? We'll be starting, this is, okay, again, since I have no idea how much, why do I keep getting the wrong windows in the front? Jesus. Spoiler alert. This will be the repository where you will be able to check out the complete source code I'm doing here with you once we're done and everything works. So a quick word about this, because I have no idea how much knowledge some of you have. So let me just quick explain. We're going to be doing a loop, and there is quite some ways how you can do a loop. What's a loop? A loop is a block of code that's run 0 to many times. So within, you see, when we write a function, we got these curly brackets that contain all the code that's being executed for this one function. And now we got curly brackets within those curly brackets, because now I'll be defining a block of code that is run a specific amount of times, and it can be 0 times. There can be loops that happen to not execute whatever it's contained in them a single time. Like when I put a condition in here, we'll be putting a condition here when the loop should run one more time, and if this doesn't match from the get-go, it won't be running at all. And yeah, I'll be defining a block of code here, and then we'll be defining a few things up here, because we'll be doing a for loop. And a for loop can do many things. And one of the things is it runs the code within its curly brackets for as long as a specific condition is true. And you can give it a starting condition, and you can also tell it what to do between each loop. So let's do this, because the picture says more than 1,000 words. So let's start with I equals 0. This is our starting situation. This means when this for loop, when this little guy, this three-lettered guy, when he sees, you want me to loop around, the very first thing, and he only does this once, is executing whatever we're putting in here, which is I equals 1, which means he sets this variable to 0. Did I just say 1? It's the weather. It's just too warm. Bear with me. I equals 0. So then we got a semicolon, because we know semicolons. Semicolons are always nice to have. That tells our little for we're done setting up the initial state. So I equals 0. This is all you have to do. Now comes the condition. Told you the loop executes whatever is between those curly brackets for as long as the condition is true as it's given. And the condition we want to have is I, that we set to 0 here, is smaller than our size x we got here. Was it x? Yeah, it's x. And this is all we have for the condition. We don't need more. We don't need less. And then something that the for loop does, something that he executes every time the loop has completed once, and before it's executed again. It's important. This is only executed after the loop has run. Each time after the loop is run, not at the beginning. This is our starting condition. This is only executed once at the beginning. And what we're going to be putting in here is executed every time one iteration of the loop is finished. And what we're going to do is we want to be counting up I. And we could, of course, assign I to I plus 1, because that's basically what we want to do. But there's a neat little shorthand for this. We can just say I plus plus or plus plus I, both work. In this case, only in this case, it doesn't matter if you say plus plus I or I plus plus. There's a difference, but we're not going to be diving too deep down that rabbit hole right now. There is a difference, but we don't need to bother with that right now. This is just a little shorthand that says whatever is in I, put one more on it, and be done. So we have our starting condition executed exactly once. We have, well, not condition. We have our starting, well, statement. This is what's done, what's executed once before everything is executed for the first time. Then we got our condition. As long as this evaluates to true, everything that's in here will be executed once more. And then once this has finished, this one's executed. So eventually I will reach a value that's equal to x. And since we want to only run our loop when I is smaller than x, this will exit and stop working. Well, yeah, it will. Stop working sounds like it's crashing and the whole program stalls. This will be finished and executing whatever comes after it when this isn't true anymore, which is the case when I is exactly the size of this. But now you say, wait, why when it's... And this is one common mistake that always happens. Even seasoned coders step into this trap. I hear some of you asking, why do you want I to be smaller than x? What if I say I want 10? I want 10 columns of cells. Then when I is 10, exactly the number I want, this loop won't run anymore and will exit and will continue with whatever comes after it. So the last time this loop runs is when I is 9, but I want 10. This is because we start counting at 0. Our first cell is when I is at 0. Our second cell is when I is at 1. So our 10th cell will be when I is at 9. We could also say, okay, we make this a bit more human readable. We start counting at 1. And then we actually have to tell it, yeah, run for as long as I is smaller or exactly equal to whatever we got here. We could also do it this way. This and this. At least for the amount of times the code in here will be executed, they will have the very same effect. But we will be going with this because we might use I to add it to something. Because remember, our cells have a distance. And we need to calculate the exact position in the world, because what we have in X and Y is only the positions within our grid, like cell 1, cell 2, cell 10. But we need to calculate the actual 3D coordinates in the world space. And we'll be needing this variable for this, because basically we'll be multiplying the cell distance by I, so we know how much further to the right we need to move our cell. And if we start at 1, we will be leaving the first place empty, because if we multiply it by 1, we already move 1 cell distance to the right, so everything shifts a bit. I hope this makes sense. If not, again, feel free to comment in the chat. What if your I is in index? It would get messy. What exactly do you mean with if we use I as an index? As an index to what? I'm not exactly sure what you're meaning with that. But I hope whatever I just stated makes sense. So at the first we want to be at the border, which is 0 times the cell distance, because we don't have to shift it. For an array. Yeah, we actually will be putting these things in an array, I think you're on the right track, because we will be putting something into an array, because it's not enough to just throw those actors, those cells out there. Since we want to do something with them, we want to know if they are alive, if they are dead, because we have to apply those rules of the game. We actually do need to use I and J. We actually do need to use them as indexes for an array. Actually, we'll be using a map. We won't be using an array. We'll be using a map, just for convenience reasons. Because maps have dynamic size, and resizing arrays is a messy business. But yeah, the idea goes in the right direction, because we need to keep track of every cell we placed into the world, so we can access it and see, is it alive or is it dead? Because remember the rules, we discussed them a bit last week, and we will discuss them again when we start implementing the actual rules, because we have to check the neighbors of each cell, and to do that we have to access this neighbors. So yeah, we will be actually using this for something like an array. I hope this went into the direction what you meant. Yeah, so now we got our little loop, and spoiler alert, we're just doing a second one, just with J, but everything the same, because we're not only making columns of cells, we're making columns and rows. It's two-dimensional, so we have to loop through both of these sizes, and also this is then size Y, not size X. Because we have to put cells in columns, we have to put them in rows, so it's rows of columns or columns of rows, depending on which way you see it. So now we got our little nested loop set up. The next thing we do is basically calculating. Remember, we want to place our cells in here. So the first thing we need is to know where in the world space we actually want to place our cell. So we need another variable. We need an f vector, and we call that location. Again, I'm a huge fan of putting all my variable declarations at the top of the function, and I know that now I need a vector, because when we take a look here where we set a location of our mesh, the location usually is a three-dimensional vector, which is just an f vector. So this is what we're going to be needing here. And we'll only be using two of those of these axes. I mean, we live in a 3D world, but we only have a 2D grid, so we'll only be using two of these. So our Y component will be, and this might be this. Now let's first write this and then answer the question I think that will be coming. I need to peek into my chat. Okay. I'm counting in I my X axis size. So in I, I'm counting at which place on the X axis I am to put my cell in there. But now I'm using Y to calculate the position, which is I times cell distance plus our base location X. And this even makes it even more confusing. And And there is a not less confusing reason for this. Let me just quickly write out the second line as well for our location X, which is J multiplied, what's the question mark? Which is J multiplied by cell distance plus base location Y. So at first, what am I doing here? And then I'll be answering why do you put your X stuff? Because again, I'm counting my X location in I, and I'm also adding the X base location from where we want to have our grid placed. Why, when I'm putting this in Y? The reason is quite simple, because Unreal Engine has these axes swapped. Then again, it has to be, it has to do a bit with from where you're looking. And if we go into the editor, where's my player start? There. So here's our player start, and the arrow is where he's looking at. And yeah, there's something. There's, what's that? That's the sky sphere. So here's our player start, and this is the way where he's looking at. And this is the default orientation. All I did to get this empty scene was delete the chairs and the floors from the default scene you get when you just create an empty scene, an empty map. And this is the default direction the player looks. And if you look into this direction, the axes are swapped to what we actually want. Because from when I start this, I'm looking straight forward, right? I am looking this way. So I want our X to be in this direction of our play grid, of the field, of the grid of our cells. I want our X to be like this, because then it matches perfectly up from what you know from your math class in, I don't know, whatever, in Germany would be 5th grade or something. If we're looking into this direction, this would be our x-axis, and this would be the y-axis. This would be if I'm expecting the grid. Wait, let me show this at the example that actually works. This is our x-axis because that goes to the side, and this is our y-axis because this one goes up and down. And if I manage to move around a bit, and this is our player looking into this direction. So this is what we expect to have, or what we define what we want to have. That this is our x and this is our y. Unfortunately, you can see it down here if I rotate this like so. If you look at the little thingy down here, you can see that looking into this direction, the thing going to the side is actually the y direction. The thing and the thing going up and down is the z direction. It's not even, it's none of the both. So the axes are a bit swapped. We could fix this by placing the player at a different location and a different angle. There's many reasons or many ways to do this. As always, there is only one solution to a problem. Usually there are many solutions to a problem. One solution would actually be placing the player start, including its rotation to where it's looking at a place so that x and y from what the engine in world space sees actually matches up with the x and y of our play field definition. That's one way you could do it. I was a bit lazy. What I just did, and this is actually supposed to be, like I just said, this is an x, this is even z. to make this even more confusing. Because this is when we look at it, okay, it has a 180 degrees rotation. So if we actually would give this a 0 degree rotation, it would look into the other way, and things would already be, well, not that much different. Just the direction, if we add or subtract from y, would be different. Yeah, but this is I just kept it at this, and again, there's many solutions to one problem, and my solution just was to put my locations in the axes that I actually see. So at the current position, the player looks, this is Y and this is Z or Z, depending if you're American or British English speaking or Canadian. I think they use both sometimes. I think Canada, they use Z more than Z, don't they? I don't like the Z because that sounds so much like C. So I use Z because then you know I don't mean C. Even we're coding in C++. Yeah, now there's something to think about. So yeah, two solutions. One would be to place the player start somewhere, including the matching rotation, so the axes of the engine match up with the axis of our playfield. The second is to kind of map the axis of our playfield to the axis the player sees. And our player currently sees this as Y and this as Z. So this is why I put the X location of my field into the Y axis, because that's how the player looks. And the same goes for my up and down, which is mathematically defined for our play field, the Y location. The way the player currently looks into the scene, up and down is Z. So this is why I'm writing my X location actually into Y and my Y location into Z. So yeah, so much for that confusion. Again, many solutions to the same problem. If you want, if you totally insist, we can change this as part of the maybe bonus at the end when everything works. We could actually do this. We could put this into X and we could put this into Y, and then try to find out where do we have to put the player start and where do we have it to look, so that everything matches up. We can do this. But for now, just bear with me. We'll be keeping using those, because that's actually the default location when you create an empty scene, and I just kept this. I don't know why. I just did. So now comes, finally, after so much talking about other stuff and so much just doing a loop and assigning a value into a variable, stuff we basically all know by now. Now, finally, something interesting. Because now we're at the point where we actually put our cell, our actor, into the scene. Oh, Kundenbetreuung! Hi! Hi there! Greetings! Do I do also often in other projects swapping Y and Z axis? Depends. In Unreal Engine in the past, I actually happened to have to swap axes quite a lot. Yeah, because for whatever reason, the axes in Unreal Engine are never what I expect them to be. The thing is, this has a rotation of 180. Let's just for trying, let's put this to 0. He's looking the other way now. So let me see, I can place myself just behind the player start. So now we have a rotation of exactly 0. Our player start now, where's my, here's my magnification, cool. Now here, this is the player start I have selected, and the rotation is 0. And no idea why it says -0 there, but well, -0, -0, +0, it's basically 0. We have a rotation of 0 for all axes. So this is the most natural way a player can be and the direction he's looking at. Anything else, and he would look into a different direction than just straight ahead. And I've aligned my viewport to line up exactly with the direction. Let me get this magnification out here for a second. So this is the direction the player's looking now. So if I place myself directly behind it to line up the line of sight in the editor, so it perfectly lines up with whatever the player's currently looking at, and you look here at the axis, it's still completely messed up. You got X is your forward and backward, Y is your sideways, and Z is your up and down. I don't know, I'm used to X being sideways, Y being up and down, and Z being back and front. I can totally live with, I think, how Unity does. I'm actually not sure how Unity, if they have that swapped. I'm also totally fine with Y being backwards and forwards, because then it's like looking at a sheet of paper. If you draw a graph on a sheet of paper, you have to look down, so Y is up and down. I'd be perfectly fine with that. So in this, like it's shown there, X and Y being swapped would be totally fine, but this is completely messed up. None of the axis is into the direction that I would expect them to be. And this is, as said, this is while the rotation being at completely 0. So really, naturally, in the world space, just looking straight ahead. Just going to be putting this back to 180. So when we start rendering our stuff, we actually be seeing it, because this is the center of the map. The 000 coordinate is somewhere around here. Yeah, and this is the reason, and this is also the reason why I did this, because I am so used to just swapping around axes in Unreal, because they rarely, if ever, match up to what I expect them to be. So we have to map them around, and I just have to do my X. I have no idea why they did it that way. I mean, if you're just looking straight at X being backwards and forwards, that's completely messed up. Again, I would be fine with X being backwards forwards, but Y being backwards forwards, but if you're looking just straight forward with no rotation, X needs to be the sideways thing, and it's not even that. I have no idea why they did that. It needs some getting used to, at least for me, which for me is totally fine in the end. I got used to it, and I personally prefer just mapping my axis instead of changing where the player looks, because I want, at least this is the thing I want to keep consistent. If the player looks forward, he looks forward, and if he's rotated in the one direction, he looks down. So yeah, but this is I think this is personal preference. You have to decide which way you prefer, if you map the axis or if you just adjust the rotation of your viewport of the camera. In Unity, Y is up and X is forward. Seriously? This is as messed up as this one. Y is up, that's fine. Y, at least they got one axis right. Y is up and X is forward. Okay, so they got X and Z swapped then. yeah, it's still messed up. It's still messed up. I think humans are not supposed to be thinking in 3D. I don't know. Even if we're living in a 3D world, in the real world, naturally, but for whatever reason, I don't know. Maybe there's a reason to all this axis swapping that I don't know yet. If you do that, if anyone of the fine people watching this know why engines actually place their axes like they do, or name them, I mean, they're placed all the same, they just name them differently than I would expect it. If anyone knows the reason why the axes are named how they are, please do tell. I would very much like to know. So, but since we're already 2/3 into today's time, let's finally do something super interesting. The thing we always wanted to do. We got our actor and now let's place it into the scene, or let's spawn it. Let's spawn our actor. And there is a very convenient function. If you know Unity, I just forgot how it's called in Unity. I think it is something with spawn as well. But it works. It works pretty much the same way. You just have a spawn actor function. Yeah, and maybe I'm not mistyping this. And you can just tell it what you want. You can tell it like, okay, look, this is my actor. I want this to be placed somewhere. Need to peek there, and you can see it's in dark red because we don't have this as a function of we're in a component, and we don't have this as a function for a component. But we get to it by, done too much PHP recently. We have a function getWorld. And this is a very important function we'll be using quite a lot eventually, because this gets you, the world. This gets you everything that's outside of your actor and everything that's out there. And the world actually has, and this is the reason why we're going to be using this quite a lot eventually, the world has many things to offer for us. One thing it has to offer is, and I hope I'm pronouncing this even remotely right, like Uatku or something remotely like this. Hi there. Greetings and a wonderful evening if you're in a time zone similar to you, or maybe a nice day. Hi. Depending on time zone. So the world then has a spawn actor. Look at that. How convenient is this? This has a spawn actor function. This thing will actually, this requires a lot. Just only 80K. All right, 80K. That I can do. Hi. This wants a lot. First of all, it wants the class of the actor that it's supposed to be spawning. Then it wants the location. It wants the rotation. Okay, that's easy. We can do that. Location we're just calculating anyways, or we just have calculated. Rotation is easy. We just set this to 0. There's a very convenient way to do this. And then, and this is the interesting part, it wants spawn parameters, and we need to define these because that's a variable that's also passed by reference, so as a pointer. So, by the way, a quick Google showed that actually X is right, Y is up, Z is forward. Yeah, this is exactly how I would. This is X, this is Y, and that is Z is, yeah. This is actually how I would expect it. So Unity is on my side with this, and as I said, Unreal has. Maybe it's a legacy thing because the first time I've ever done something with Unreal was when Unreal Tournament 2003 came out. I basically only got the game because it came with the Unreal editor. Really, I had no interest in the game. I heard the news, yay, new Unreal Tournament 2003, whoop, hype. And I was like, yeah, I don't care. And then they said, and of course it comes with the Unreal editor, so you can create own content. I didn't even hear the end of that sentence because I was already down at the store buying my copy of Unreal Tournament 2003. And they had I was already confused with, I remember that I was already confused with how they named the axis back then, when I just fiddled around with Unreal Tournament 2003 maps and stuff. So maybe it's just a legacy thing and they never changed it because it would confuse people that got used to it so much more. I don't know. Maybe eventually I will get a chance to talk to someone at Epic who actually knows, to ask them why it is the way it is. I don't know. Maybe. Till then, it remains a mystery. What will not remain a mystery, though, is the spawn parameters. We need to, you can see, not sure if you actually can see, you see this little ampersand here, which tells us this thing is passed as a pointer. Well, pretty much as the vectors and everything, because remember, we can't pass whole objects or data structures as contents of a variable, because everything that's be put into a variable has to be able to fit into a processor register. So there's only that much space, 64 bits usually on modern computers. So we have to pass this as a pointer, and we can only pass pointers of things we created. And since we all, in this case, in a different project or a different situation might be different, but in this case we're passing always the same spawn parameters, so we can just define them outside of our loop. We set them up and define them and just use them here. So again, we need a new variable, which is, let me see if I can get this out of my head. Something with spawn parameters, f-actor spawn parameters, spawn property. Let me see. It's actually actor spawn parameters. It's actually f-actor spawn parameters, and that's our spawn parameters. So, and then we can put something in there. First of all, we have to properly create, I think, an empty. Oh wait, it's this one. So, yeah, this might be redundant. Assigned declaration assignment can be joined. No, it's not. Okay. So here we just declare the type of our variable, but that thing is, it's a complex data structure with stuff in it. So we first need to create a proper empty version of it, and then we can set things like the owner. Which is, it's not super important to set this, but well, it's always nice. And we set this. No, let's start a bit further. What is this? What's the owner? Everything, or well, almost everything in the world is owned by something else. Like when you have a component that you have attached to your actor, this component is owned by this actor, because they have a relationship with each other, because the component offers stuff to the actor and the actor calls things from the component or tells it to do stuff. Also, an actor has an owner, which could be like the world or another actor. So in our case, we'll be just setting the owner of the actor will spawning to whatever owns us. Which I think could be... No, wait, we're in a component, right? No, I know what it is. We're in a component. And the component is owned by the actor it's attached to. So the actor we're spawning is also owned by the actor that has this component attached to it that spawns it, which in the end will be the game state. Because remember, a bit earlier today, we created, if I find the right directory, we created a game mode and a player controller. We'll also be creating a game state, because we're just creating a component. This component has to be attached to something. And since this deals with setting up the playfield, so it's quite a central thing, we'll be placing this at the game state, because the only thing that's more global, common, and central than the game state is the game mode itself. And for whatever reason, I like to use the game state for that. You can put this into directly into the game mode as well. Maybe we do it. I don't know. Let's see. We're not there yet. So we have an owner. And this is, we don't have to set the owner. We can just leave this at whatever Unreal Engine puts there as default. But for completeness sake, so we know we can set the owner, we just do it. But now comes something sometimes even important. There is a no fail flag. B, no fail. B, because it's Boolean. Again, Unreal Engine likes to prefix all its property names and field names with a letter already telling you what kind of type it is. And we set this to true. Why is that? No fail. A spawn can fail under certain conditions. Like by default, you cannot spawn an actor inside of another actor. So if you spawn your actor at a place where your actor would intersect with another actor, and remember, the floor is an actor, walls, everything are actors. So the spawn will fail. And the thing just won't spawn. We can force it to spawn it anyway. I think in this case, this isn't necessary, because we won't actually be intersecting with anything unless we set the cell distance to a value lower than the actual size of our cells. Then the cells could intersect with other cells, which we won't do. So we're safe. So we wouldn't need this, but I want to show you that this exists, because sometimes you want things to be able to spawn in situations where it would usually fail, and it intersecting with. I'm not sure if the help above that tells more. Determines whether spawning will fail if certain conditions are not met. Well, okay, it doesn't really say all the conditions. The intersecting with something is only one of the conditions that might cause the spawn to fail. There are more conditions. If you're interested in what the conditions are, just check out the official documentation. If you want it to still spawn, if you say, engine, I don't care. I just want my object to my actor to spawn, no matter what. I know it's half in the wall or it's intersecting with something else, but that's totally cool. I like it like this. You can actually tell the spawn function, don't care about anything, just spawn me that actor. And this is basically what the true does. Many words for so little meaning. So we just tell the spawn actor function in cases where it would usually fail for reasons stated in the documentation, because I forgot them. don't care, still spawn it. I don't think we actually need this because those situations will, I don't think we'd run into these situations, but I just wanted to show you that this exists and what it does and why you might want to use it sometimes. I actually had a situation because I was spawning game tiles and they had to be very closely together. So that sometimes they were so closely together, the spawn function thought, whoa, hold on, dude, they're intersecting. I'm not spawning you that. So by this, I could tell the spawn function, don't care. It's perfectly fine. Just spawn me the damn game tile, which then it did. So those are our spawn parameters. And now I completely forgot what we need to put in here. We need to put in our class. Oh, and for classes, for another class to be usable, we have to include it. Remember, everything that we haven't done in our own code, but we want to use, we have to include it. So we'll be including our cell actor header up here, because now we're able to tell a cell actor to put this there, like so. But I think this is not right. We need it. Let me check my notes so we can save a little time. Yeah, just cell actor. Wait, let me actually check. Where is this coming from? Why is my mouse not working now? Just to save us some time and experimenting stuff. See, because I missed something. Is this thing used anywhere? Why is that not working? Sometimes my IDE, go to declaration, getting what? Ready, press escape to cancel. Okay, sometimes my IDE just doesn't like me. Let me just quickly check something, how we actually pass it, because I don't see it anywhere. Oh, okay. Yeah, this has to come from somewhere, and the way I planned this, we're gonna be setting which actor we actually use to spawn our cells. Right, the way I originally planned. See, this is the difference. This is the difference between just recording and cutting for YouTube and doing this live. Sometimes, especially with 35 degrees outside, you just forget for a second what you actually had planned or how you did plan to do it. I want this to be settable from our blueprint. Remember, we'll be creating a game state blueprint, and onto the game state blueprint we will be attaching our component, and then we will call from the game state blueprint. We will be calling our init field function from our C++ component, but I want that the actual actor we use to spawn our cells, I want this to be configurable and settable in the editor. And we've done this in the previous weeks. So what we do is we create a public property, maybe properly indented, and I call this one cell actor. So no, just cell actor. And we need a type. This is why my IDE put the A in front, because we need a type. We need, of course, for every variable or property we create, we need to define the type of which it is. And here's something a bit more special, because this is a T subclass of. an actor component. If I would just do it like this, this wouldn't work anyways, because again, you can't put a complete object into a variable. So this would work. But then again, this would be an existing instance. This would be an existing instance of an actor already being created, because this is a reference, a pointer to something that's coming from the A actor class. So basically any actor that's somewhere there. Oh, Agent, you are 003. Hi, grüß dich. A wonderful evening to you. Hi there. So this would actually need to be an instantiated, usable object of an actor, which we don't want, because we want to create all these objects. We don't want to use one object that's already created. So use this subclass of, which basically will store a reference into this variable of the class that's supposed to be used. It won't actually store an actor in there, especially not an instantiated, a reference to an instantiated actor. This is kind of give me the name of the class that's supposed to be used for this. Yeah, that's basically it. This is in layman's terms, this is under the hood. This does a bit more, but I don't think we need to dive too deep into this rabbit hole, especially because, to be quite frank with you, I haven't completely understood this myself yet. And there's one more thing, and that's super easy because we've done this quite some times. I said I want this to be settable in the editor when we're here. I want that I can click with my mouse here and set the value of this option. So to do this, we again declare this as a U property, and we make this edit anywhere. This should do it. We could also do a blueprint read write, because why not? But I think this is redundant. I don't think we actually need this. But it also doesn't hurt. I think the edit anywhere is enough. You know what? We just do it with the edit anywhere, and if it doesn't work, we know that we need to put the blueprint read write. But this should do it. So now we can set the class of the actor to be used in here, and now we can properly pass this to our spawn actor function, and now it should not be red, but this bluish color there, because that's totally fine. So next thing we need is the location, and we already calculated this one. This is our location variable that we set here. Then we need a rotation. Rotation, I said we're just putting no rotation there. And also this needs to be passed by reference. And I think... Oh, and thanks for the host, by the way. IGDA. Thank you for the host, and welcome. Welcome you and all the fine people coming with you. We also need a rotation. And we need to define this. Rotation is not, interestingly, rotation is not just a vector. In Unity, wow, they have quaternions. Yeah, it's a bit, maybe quaternions are the reason. But instead of f vector, we also got an f rotator. And that's basically our rotation. And there's a very convenient thing, because we can just say no. Oh, come on. Oh, auto-completion, why are you doing this to me? Why is that not working? Oh, because it's F rotator. Remember, it's always the Unreal specific things, they always have the prefix. So F, see, here we go. And that thing has a static thingy 0 rotator, which is basically the same thing as saying, let's do this just for demonstration purpose. I could just say I want an F rotator with the values of 0, 0, and 0. I want a rotator with 0 degrees pitch, which is X, 0 degrees yaw, which is Y, and 0 degrees roll, which is Z. I could do that, but since I'm lazy, I'll be doing this because this is a shorthand. This is a convenience function to make a shorthand for this, and also it's a bit more readable. I mean, of course, we say, yeah, okay, he needs a rotator. Okay, 0, 0, 0. All right. And then when you've read all these numbers, you know, the guy doesn't want any rotation. He just wants to look straight ahead. This is not only less to type and quite short, it's also a bit more easy to read because you see, okay, 0 rotator, okay, he doesn't want any rotation at all. So that's fine. We also have to pass this here. And what else do we need? What else do we need? Oh yeah, our spawn parameters. And that's it. Our spawn parameters, and I think these also need to be passed like this. Let me just double check. No, for whatever reason they... Oh, yeah, I don't know. They don't need to. We're also getting something back from the spawn actor, because what we're getting back is a reference to the actually spawned actor. So if we want to remember this, we can say spawn. Is that written? I got problems with typing. It's too warm. Spawned cell. So we can say spawn cell equals whatever's coming back from get world. And you can already see this is my most common mistake, because the equal sign has this little squiggly, this red squiggly underline, which says, dude, here's something terribly wrong. And if I hover over it, it says it doesn't match actor and actor pointer, because I need to put the asterisk here, because again, I'm not getting a complete actor object. I'm getting the reference, the pointer to where it is. And we will talk in depth about pointers when we got this one finished. I think we will, because we only got like 15 or 20 minutes left till it's already time to call it a day for tonight. And unfortunately, we haven't gotten that much. So let's continue. So we get the things at least spawned. That would be something. So let me check my notes so we can save us some time. So I was about to say something. What did I want to say? Oh yeah, pointers. When we got this Game of Life thingy running, when it's complete, and maybe we even did a few bonus things, depending if you guys want or not. The next thing we will be doing after the Game of Life's done, we will be talking a bit about pointers with examples, how they work, why they work, and why they sometimes don't work, and how you can get your engine to crash with them, which is very, very easy. So we're going to spawn cell, And now we do something that most people don't. Unfortunately, I always happen to find spots where people don't. But we'll be doing some error checking. And we'll be checking if we got something in spawn cell that evaluates to true. Or to put it the other way around, that does not evaluate to false. Which is basically everything that's not actually false or a null pointer. Because what this thing, if it fails, if for whatever reason, and there's quite a few, there's even reasons where this doesn't help, where the spawn failed, it returns, I think, null. I think it just returns a null pointer, which evaluates to false. So anything else but a null pointer or a literal false, or I think a zero, the number 0 also evaluates to false. So anything else will evaluate to true. So this is totally cool. We just check if we got anything in here besides the few little things that would evaluate to false, because that we don't want. And then we can do things. But I think, yeah, more stuff to be done here next time. We'll be doing something here because each cell, we will be telling each cell at what coordinate it actually is. And the reason for this is because I want to place the checking of the neighbors. I want to put this onto the actor. I want each cell for itself to determine if it's dead or alive in the next generation. Again, nothing to do with the Star Trek show of the same name, even if that show was quite cool. So we'll be telling each cell, each actor, on which coordinate in our grid, in our play grid, not the world coordinates, but inside our play field, our game grid, on which coordinate it is, so it knows which its neighbors are. Because if it's at 4, 3, it knows all the ones around, so it can easily determine what are the coordinates of my neighbors. But that's something will be doing next time. Yeah, and I think, Jesus Christ, these scroll bars sometimes just don't work today. Something's up. And we put another to-do in here. Because, as said, we're closely to the end of tonight, so we need to make a few plans for the next show. By the way, the next tutorial session will not be next week. The next tutorial session will not be next week, Thursday, because next week and the week after, the actual game Devcom takes place. And during the course of the actual Devcom, tutorials will go into mid-season break. Doesn't that sound cool? So we will be doing a short mid-season break because the actual Devcom will take place, but we will be continuing right after. So let me see. In date terms, this would be Devcom is from the 2 weeks from the 17th to the 30th. Those 2 weeks. The 20th, that would be next week, Thursday, is an actual Devcom day, so no tutorials there. The 27th, again, is a Devcom day, no tutorials there, but the 3rd of, what's that, September? September. 3rd of September, so the first Thursday, right after Devcom finished and wrapped up, we'll be here again, continuing this. Not so cool, since we have to wait longer. They do it on. It works on TV, right? Mid-season break, always the most hated thing. Yeah, well, maybe cliffhangers at the actual end of a season are worse. Okay, so the second worst thing that could happen. But yeah, as I said, the next 2 weeks there's the actual Devcom taking place, and it would just collide and interfere from the schedule. So we're postponing this. The next time we'll see each other right here would be the 3rd of September. But as said so many times already, if you have any questions or if you just want to talk about stuff, especially this kind of stuff, feel free to tweet at the hashtag, tweet at the Twitter handles, contact me on the Devcom Devcom Discord. We can talk about it on the Devcom Discord. There's so many ways we can keep talking about this even while we're taking a short break while actual Devcom is taking place. Will I keep streaming on the other channel after this one? You mean tonight, like we did the other weeks, that in a few minutes when I will wrap up here, that I will continue streaming on our... Yes. So you still have a chance for things to ask. You need more sessions. Thank you for your time. Hi! What? You need more sessions. Even more sessions. What? Reply. Oh. This is the new reply feature they told about. I haven't. You can reply in chat now. I actually totally have not tried this out yet. Yeah. By the way, Nico, hi. Didn't know you were there. Wait a sec. Yeah. I'm not. I hope this still works. For me, it still works. I still have the one with sunglasses. So yeah, Modern Genesis. We will be having a little after show party on the other channel right after we wrapped up here. Yes, absolutely. So okay, we put it here to do. Let the cell know on what coordinates on the playfield it is. So another thing we want to do is to remember the spawned cell actor in a local map stand-in for an array. Again, I'm using the map kind of as an array, but maps are way more convenient than arrays. You don't resizing arrays. I mean, we could basically. I mean, we know the size, so yeah, but we have to dynamically size them. Maps are just more convenient. I like using maps, so we're doing it with a map, but we're using it basically as a more convenient version of an array. That's basically what we're going to be doing there. And that is actually what we'll be adding here. And in the cell actor itself, we'll be adding to receive this. So the cell actually knows where it is on the playfield. Well, yeah. And determining the neighbors, if it's alive or dead. You could say, hey, having the cell itself decide if it's alive or dead, bad idea. Because what if the cell doesn't want to be dead? So it could always tell you, no, I'm alive. It's good. I'm totally alive. I'm not dead, even if it's supposed to. Yeah, we have to trust our actors with this. Again, it's a bit of how you design your code, how you structure your code. We could determine if a cell is alive or dead in the next generation into here, but I just like to put it cancer. Yeah, this would basically be cancer. So the cell is supposed to be dead, but it tells you, no, I'm super fine, I'm alive. This would, maybe this could be, I don't know, maybe we code cancer in there. So there are cells that should be dead, but yet they are alive. See? And this is one of the reasons why I want to put this into the cell actor, because then you can extend it a bit more easy, and each actor, because it's the state of the actor, and well, in my opinion, it belongs more into the actor. Also, I want to show you how these objects can communicate with each other, because there's something we need to do here to actually be able to call something on our actor to set those values. I want to show you how our component here can communicate with the actor we just spawned, which we also need to do when later on triggering the, hey, you, determine if you're alive or dead, because that's another loop we'll be going through here. And yeah, there's quite some reasons why I wanted to put it there. And yeah, so let's see, because basically, this should already give us, if we take care of this red squiggly line here, which basically tells us, dude, you have no declaration of this function in your header, which we definitely need because we want to call this from our game state blueprint. So we not only need to have this in the header just because we always need to have it in the header, but also to be able to tell it, hey, you know what? You're a U function. Oh yeah, you're a U function, and by the way, you're blueprint callable. You can be called from a blueprint because why not? And that we still do, that we quickly do. So we go back into our project, compile the C code to see if everything's cool or if I made a horrible mistake that even keeps it from compiling. And while this compiles, cheers. So, looks like it compiled. We create a game state, actor, pawn, character, player controller, game mode based actor component. We don't have one here. So we open all classes and look for game state. And there it is, game state base. We call this BP our game state. Open this up. And now we do one of the nicest things you can do when you coded your stuff in C++. And I even magnify this so you can share the joy. We hit add component. And up here in the search bar, we look for field. And there's a field system. I have no idea what that is. I don't think that's something I did. But there's a field handler. Let's use this one because field handler totally sounds like the one we just made. And there it is. Look at that. And here's our cell actor selection. Field handler component, cell actor. Remember when we set up here the cell actor with the subclass of an actor and back into the editor. Here it is. Here's our cell actor. And now I should be able, there's a lot of stuff already here, and I should be able to find our cell actor here and select it. There it is. Now I got our cell actor selected there, and now we go into the event graph. And we did this, I think, in the very first week doing those tutorials. What we're going to do now, this is the blueprint graph of our game state. And I want to do something at begin play because I want to do it right when everything starts. And we're going to call our init field function from a blueprint because It's fun. So we just drag our field handler from the list of components. We just drag this into the blueprint stage, and there we got a neat little handy reference to our component where we can say call function init field, and look at that, everything's there. Field size, I don't know, let's do 20 by 20. Let's do 20 on the x-axis. We have a bit more space on the y-axis. Wait, we actually got, we got 16 by 9. So let's make this 32 by 18. So this should perfectly fit onto our screen, shouldn't it? Cell distance. I know that our actors are 100 units wide, so let's set this to 110. And base location 0. Let's keep this centered. Let's keep this centered. We have 18. Oh, see, now we need to do math. Oh, that's inconvenient. We have 18 cells on the x-axis, and they are each 110 units apart. So that's, you know what, just leave it at 0.0. It's too warm to do highly complicated mathematics. Maybe we write a function. You know what? We're going to be writing a function in our component that does all this math stuff for us. Yeah, we do that. We absolutely do that. And that's basically it. Yeah. For some reason, that's it. We call our C function, give it all it needs to know, compile and run. Then we need to go into the game mode to actually set our game state class to our one, compile and save this one, and see what happens. And look at that. And completely the wrong way around. we got 32 up and down, and let's try and fix that. So it's actually even those are swapped, or are they? No. Okay, sorry, no, they are not. That's just that's just the temperature messing with me. The code in the engine did everything right. I mentally swapped X and Y for whatever reason. We want to have 32 in the width and 18th in the height, which is Y. Everything's good. It's yeah, see, that looks nice. There we got our game grid. And I should be able to click, oh, look at that. I should be able to click on those to make smileys. Yeah, so at least something we got working tonight. We have extended our game actor, our cell, so we can click it to toggle the states between dead and alive. We also tweaked the meshes a bit. We made the sphere a little bit smaller, and we adjusted its location and everything. And we created a new component, a new actor component that we put onto the game state, and that where the game state can then just tell the component, hey, you component, give me a game field of this size, please. And we actually get it. We get lots and lots of actors placed without having to drag them manually. You can see them here on the list. There's quite a lot of them. How many are there? It actually starts counting by 1, which is nice. And it goes to 575. So actually the first one is not counted. The first one is just cell actor, and then the second one is cell actor 1. So we actually have 576 different cells here. And we can, of course, overdo it a bit. We could say 100 by 100. I'm not sure when it starts lagging too much, because it eventually will start lagging hard. Oh, you can see it already takes quite some time to spawn all these actors, but well, here you are. Okay, if they are little spheres, you can hardly see them. So you know what? Let's give them an initial state of being alive. We can easily do this, because in our constructor from our actor, we just say, hey, set the cell to dead. And so, just so I can delete it a bit more easy, I just immediately call set cell alive. Of course, I could do it instead of this, but since this call is now just for demonstration purpose, I can just delete this and have everything back to how it's supposed to be. So I will leave this in, even if it's completely redundant. Compile. And play. Take some time. And look at that. Isn't that a nice wall of living cells? And now you can just click randomly in there and make them dead. I mean, that in itself, it could be... Maybe for next project we do a minesweeper with this. Yeah. Or let's, I don't know, because I'm in the mood, let's do 256 by 256. And let's space them a bit more. Let's make 200. Nah, let's make 150. 150 sounds more cool. So, and this might take some time. Already everything set up. Oh yeah, you can see this already. This takes some time now. Because 256 by 256, how many cells is that? Give me a calculator quickly. 256 by 256. This is 65,536 individual cells, and this might start lagging a bit and tanking the frame rate if even getting hard issues navigating. Yeah, but this is it. This is our huge 40K playfield. Where I can still, it's a bit tiny, well, you can hardly see it, but I can still, each and every single one, I can still click and make it dead. The spheres are now so tiny. I think I hit one there. Yeah, look at that. I even managed to get one of the cells alive again. Of course, you could always navigate closer to it. But yeah, this is a huge 256 by 256 field of our neatly done actors that you can click to toggle between that, and you can see the holes I'm punching in here a bit. Now we can paint a picture pixel by pixel. Yeah, you could actually do this to make a monochrome one color pixel by pixel image. More array effects already setting in. Yeah, but this is basically it. You can, and this is why I said let's make this parameters. Let's not make this hard coded. You can set the field to any size you want. All right, we already got a plan for next time again, which will be right after Devcom concludes, which will be in 3 weeks from now, because the next 2 weeks Devcom itself will take place, and which will give me quite a lot of time to think about more stuff I can do with you. And I do think that the next time we'll be sitting here together, we will finish this, because there isn't that much to be done. As said, just stopping this for my computer's sake, or else it will go up in flames or something. We got our to-dos here, if I find them. some to-dos here, and then we need another loop and maybe another function here that actually takes care of triggering each cell to calculate if it's dead or alive in the next generation. Then to tell each cell to show its state for the next generation. Why we have to do this separately, I will explain next time, because there's a reason from how things work, why we need to do this separately in two ways. We need to make them able to be talked to each other, so our field handling component can tell each cell at what location it is. And also we need to remember all the cells so we can loop through them and pinch each of them, then tell them, hey, you, go, do your thing. And then we'll actually have, there's one little tiny thing that's missing, but that's really, really tiny, because we need a trigger. We need something to trigger the constant calculation generation of the next the generation of the next generation. That's a funny one. Because at first, when we start the game, we actually want to have it like this. Let me just put more sensible numbers in here again. That's maybe a bit much. 110 was okay. Compile, save, and run. Let's make the cells being dead initially again. So, and just for completeness sake, let's compile it. Because at first, when we start the game, we actually want to have a situation like this. The grid is just sitting there, and we can, if I hit them, and we can make them, we can change the states of the cells, and we say, no, I didn't want this like this, and I just wanted that, and so forth. We can make little Tetris blocks in here and see how they survive. And we want to be able to do this while nothing happens, because we need a bit of time to set up our patterns and how we want the Genesis generation to be. And then we need a way to trigger that the game then starts calculating all the next generations. And we'll just be doing this by hitting the Enter key, which is super easy, really not much of a hassle. And again, we'll be setting up a little bit of blueprint to listen to the Enter key, which will then call a function of our C++ component. So the component then knows, okay, it's supposed to do all the calculations and show you all the following generations. All right, so this is what we got for today. This is what we're going to be doing next time, again, which will be in 3 weeks from now. Or if you're watching this later on YouTube, it's whenever you want to watch the next episode. So thanks a lot for being here, for staying with me. And again, if you have any questions, tweet to the hashtag, tweet to the Twitter handles down below. Post it as comments on YouTube. Join the Devcom Discord. There's a channel. There's a Devcom Tutorials channel. Feel free to ask your questions there. Or, I don't know, smoke signals. I might not see them, but if you're close enough to me, smoke signals might work. I'm not so good at Morse code, so that might not work that well. Anyways, there's many ways where and how you can place your question. And even if you don't have any questions, even if you just like to talk about this stuff, you're more than welcome to do so. All right. This concludes today's episode 4 and part 2 of Conway's Game of Life, of coding for Unreal in C++. Again, thanks a lot for staying with me. Hope you enjoyed it. And for those of you who still smoke signals, yeah, who knows? Maybe. They used to work back then, back in the days. For those of you who are not totally tired yet and who are still up for a little chat and a little tinkering in Unreal Engine, who wants to see me trying to do stuff in an actual Unreal Engine project that we're currently working on, just stick around. You don't have to do anything because I will be raiding this channel over to the other one, and I just need to copy paste me the name so I can trigger the raid properly. I will raid you over to the channel of our studio now, because I will now work some magic. Let me fetch the other keyboard. Yeah, because I will be starting a second stream for a while on the other channel, and you are more than welcome to join me there and spend maybe another hour, depending on how long my internet lasts. The last few times around 10. I keep getting issues with my internet, but that's better than nothing. So yeah, let me just fire that up quickly so we're set up, and maybe a little bit of the nice Devcom background music already. So the other one should be live shortly, so I can raid you over. Again, if you have some time and if you're in the mood, if you don't want to go to bed with me, stick around for a bit more of tinkering and just random chatting. And if your way guides you to other places right now, again, thanks for being here, and see you again 3rd of September for episode 5 of Coding for Unreal in C++, which is part 3 of, and I hope the conclusion, the finalization of our implementation of Conway's Game of Life. That all said, wherever your path may take you, have a nice time, see you around, and bye. Let me find the end screen, and then, yeah, it's that one. All right, bye-bye.